welcome to my class. I am Sunita madam. Today I am going to teach one of the important topic in physics, that is sound waves. Let us discuss the theory part based on the topic sound waves. Then after that one I will discuss few MCQ problems based on the same topic. If you listen the theory class carefully, then easily you can solve multiple choice question based on the same topic. Okay. Therefore, understanding the theory part is very important. This topic is easy. You can understand. First one, sound waves. What is sound? A sound is a vibration that propagates through a medium in the form of a mechanical waves. Sound wave is nothing but a vibration. Sound is nothing but a vibration. Now I am talking, it is producing a sound waves. You can see the vibration. If you touch your neck, you can feel the vibration. You can feel if you touch your neck when you are talking, you can feel the vibration. Even your voice also, it will start vibrating. A sound is a vibration that propagates through a medium in the form of a mechanical waves. And you know how the sound it will produce. In our throat we are having the vocal cords, that we will consider as a vocal cords. The name it's nothing but a vocal cords. When you start producing a sound, that vocal cords it will start vibrating. Okay. When singers, when they are singing, then when we will talk, that vocal cords it will start vibrating. It will produce a sound. Then already we learned sound is a vibration that propagates through a medium. Yes, to propagate means to travel sound waves from one place to another place. Otherwise it needs a medium. Therefore sound wave is a mechanical wave. What is mean by mechanical wave? Mechanical wave is nothing but to propagate a wave it needs a medium. Without medium it can't propagate. Propagation means it can't travel, otherwise it can't reach. It will not travel from one place to another place. Okay. Sound is a vibration that propagates through a medium. That medium we will call it as a mechanical wave. Always you have to remember, mechanical wave it requires a material medium to propagate. Propagate is nothing but to travel. The medium in which it propagates can either be a solid, liquid and gaseous. The medium, already I told, mechanical wave otherwise sound wave, it will require a material medium to propagate. The medium may be a solid, liquid, even gas also. Then sound travel fastest in solid, relative slower in liquid and also slower in gases. This I will explain in the detail. Consider the figure here. This is the solid, this is the liquid medium. Then consider the last one is the gaseous medium, otherwise gas medium. This is the liquid. This is liquid, this one is gas. You know already in solid all the particles they are very close to each other, and also they are closely packed in a solid. All the materials are made up of a particles. Yes, no? In solid all the particles they will be very tightly packed. In liquid compared to solid, very tight. You can't see any gap between the particles in the case of a solid. Coming to the liquid, you can observe some gap between the particles. Compared to solid, you can observe some gap is there between the particles. In the gas, yes, this gap it will be further increases in the case of a gas. Here I mentioned here, in the case of a solid, sound travel fast. Why in the case of a solid? Why the sound waves they can travel fast? Because you can observe here, in the case of a solid, all the particles they will be very packedly arranged, very closely arranged. Once the sound waves is nothing but a disturbance in the medium. What will happen? How the disturbance it will happen? I will consider two particles here, A, B, C, D. Like this, the particles they will be arranged like this. I am naming the particles because you have to understand, no? Once the sound wave produces, it will disturb this particle. Then this particles it will move, only the energy it will move, it will disturb the second one. Then this energy it will transfer to C, this particle C it will get disturbed. Then again the same energy it will travel, it will disturb the third particle. Here the wave it will oscillate the particles. Otherwise in this case you can observe wave motion is nothing but a disturbance of energy. Otherwise the energy it will transfer from one particle to another. Wave motion, you can observe how the wave it will move. The particles itself they will not move. Solid, even particles they will not at all move. They will be fixed in their position in the case of a solid. But here when sound wave travels, you can observe sound wave travels. How it will travel? Only the energy it will transfer from one particle to another particle. Particle itself it will not travel. Only the energy it will travel from one particle to another particle. In the case of a solid, already I informed the particles they are very close to each other. Then here only less energy is required to disturb the particle. When the particles, when they will start disturbing, they will start vibrating in their mean position. Here this is the mean position of particle A. Only in this position it will start vibrating. Only in this case it will start vibrating. Vibration of the particles it will takes place. The energy it can easily pass between the particles because all the particles they will be very closely, very neatly packed in the case of a solid. Therefore in the case of a solid, when vibration is set up, transformation of vibration is nothing but a wave or a sound wave you can consider. When vibration is set up to transfer vibration from one particle to another particle, otherwise to transfer energy from one particle to another particle, it will not take more time. Within a short period of time the vibration it will occur inside a solid. Therefore sound waves easily it can pass through the solid. Compared to the coming to the liquid, here you can observe a gap between the liquid particles. Here also when sound waves produces vibration it will start, but here compared to solid, here the particles they are far from each other. Therefore here the vibration it needs some more amount of energy as compared to solid. Then vibration, otherwise transfer of energy it will be less compared to solid, because you can observe the gap between the particles. When there is a gap, to transfer the energy, to transfer the vibration, it needs some time, and also it needs some more energy also. Therefore the sound waves it will travel faster in solid compared to liquid. Coming to the gas, here you can observe the gas particles here they are far from each other compared to liquid and solid. Therefore here the sound waves to travel they will take more time, because vibration transfer of energy it will carry from one point to another point, it will take more time. Therefore from my explanation you can conclude sound travels faster in solid compared to liquid and gas. What is the reason? You have to remember here, in solid The particles, they are very packedly, they are very close to each other. Vibration or transformation of energy easily it will takes place. Therefore, sound waves travels easily. But in the case of a liquid gas, the particles, they are far from each other. To transfer the vibration, to travel a sound wave, it needs more energy. When it is needing more energy and more time, then the speed of the sound, it will become less. Okay, those who are there in the live, tell me hi. Otherwise, at least continuously listen my class, then it will be helpful for you. After the class, I will explain. After this class, I will solve few MCQ questions also. Okay. In physics, sound is defined as, according to the physics, how we can define the sound. A vibration that propagates as an audible waves of pressure through a medium such as gas, liquid, solid. Even sound waves, I don't know. Even it can pass through solid, liquid and gas. What is the definition of sound if they ask in the exam? The vibration that propagates as an audible wave. Yes, sound we can audible. Everyone, if you produce the sound, you can hear the sound. Okay. Then here sound is nothing but a vibration that it will propagate. Propagate means it will travel from one place to another place. Otherwise from one point to another point. Then it will create a audible wave. Audible wave means you can listen. Wave of pressure. Sound it will create a pressure. That also I will explain in detail. Through a medium such as gas, liquid, solid. Sound is a mechanical wave. Mechanical wave means it requires a material medium to propagate. Because, therefore, sound waves it needs a medium. Without medium, the sound wave it can't travel. Even sound it can't travel through vacuum. Vacuum is nothing but there is no medium, empty. In vacuum, sound waves they can't travel. In one question you can ask, why ma'am in vacuum the sound waves why they can't travel? In vacuum there is no particles, empty space, there is no particles. Already I told how the sound it will move from one place to another place means you will observe the disturbance of vibration of the particle. Otherwise, once the particle they will get disturbed, they will start vibrating in their mean position. The particles itself they will not move, but the energy of the particles, vibration of the particles, it will start moving. But in the vacuum, there is no particles, there is no vibration of the particles, there is no energy, there is no transformation of energy of the particles, nothing it will happen in the vacuum. Therefore, one of the important point you have to remember, in vacuum, the sound, it can't travel. Okay, you can't produce sound in the vacuum. Okay, I think everyone you understood. Next, we will study in detail what is meant by a sound wave. These are the important, very basic. Okay. Then, what is a sound wave? A sound wave is the pattern of disturbance. Yes, always in your mind you have to think sound wave is nothing but a disturbance caused by the energy traveling from the source of the sound. Okay, to produce the sound we need some source. No, without source how we can produce the sound? Sound wave is the pattern of disturbance caused by the energy traveling away from the source of the sound. Sound waves are longitudinal waves. This means that the propagation of vibration of particles is parallel to the energy wave propagation direction when the atoms are set. 1 minute, I have to adjust the power button. Sorry, I forget. 1 minute. Hello, sorry for the disturbance. I have to connect my power backup. That one I forgot it. Then in my laptop it is showing low power, means this live stream it will be disconnected if I not connect the power. Okay, sorry. Every day I will make the adjustment, but today I don't know how I forgot to connect the power. Okay, leave it. Okay, what is a sound wave? A sound wave is the pattern of disturbance caused by the energy traveling away from the source of sound. Sound waves are longitudinal waves. What is meant by a longitudinal waves? Always the waves, they will be propagating in the same direction as the particle move. This I will explain with the diagram. This means the propagation of vibration of particles is parallel to the energy wave propagation direction. When the atoms are set in vibration, they move back and forth. In next page I have the diagram. In that case I will explain. Okay, how the particles they will move back and forth. You can observe the vibration of the particles, it will happen. How the particles they will move back and forth. Okay, back and forth. This continuous back and forth motion result in high pressure. Some case it will result in high pressure, some case it will result in low pressure region in the medium. This high pressure and low pressure region are termed as compression and also rarefactions respectively. These regions are transported to the surrounding medium, resulting in the sound waves traveling from one point to another point. Okay, I will explain now. What is mean by a longitudinal waves? Longitudinal waves are nothing but the waves, they will travel in the same direction as the particle. Same direction. See, this is the propagation of the wave. Then propagation of the particles also, both also they will be travel in the same direction, one direction. Otherwise you can consider even parallel direction, both they will be parallel to each other. See, consider this is the direction of the particles. The particles they will move only in this direction, like this direction. They will move back and forth, like they will be moving in the same place only. They will be start moving, vibrating in like this, not like this perpendicular they will not vibrate, like this they will vibrate. Particles they will be vibrating like this, like horizontally they will vibrate. How the wave it will move? Wave also it will move horizontally only. Both they will be parallel to each other. When these particles, when they will be vibrating, no, when they will come closer, it will produces a high pressure. When they will come closer, no, then it will produces a high pressure. That high pressure, sorry, here low pressure, here diagram, low pressure, yes, here low pressure, that one we will call it as a rarefaction. When high pressure, that region we will call it as a compression. This is the high pressure region, this is the low pressure region. Low pressure region we will consider as a rarefaction. High pressure region we will consider as a compression. Here the particles, when they will be start vibrating, no, then only the sound wave it will travel from one point to another point. Consider this is the source of sound wave, artificial source of sound wave. This is the artificial source of sound wave. Once the wave produces, otherwise disturbance produces, here in the consider any medium, whether it is a solid, liquid or gas, you know all the medium they will contain say particles. When this disturbance happen, these particles they will be start vibrating horizontally like this. Wave also it will move like this in the same direction, otherwise both they will be parallel to each other. Okay, then here you have to remember, when vibration start, the energy it will move from one point to another point. The particles when they will start vibrating, they will transfer the energy. See here I am showing the particles, they will be vibrating like this in the longitudinal wave. In the transverse wave, they will be vibrate perpendicular. That I will explain different in the next one. Otherwise, you will get confused here. In the longitudinal, they will be vibrating like this horizontally. They will be vibrating. Waves also, it will move in the same direction. Therefore, vibration of the particle, then movement of the wave motion, otherwise the direction of wave motion, both also it will be same in the case of a longitudinal wave. That one you have to remember. Then one more thing, how the particles they will be vibrating. Sometime the particles they will be move far from each other. When they will move far from each other, then it will create a low pressure region. That one we will consider as a rarefaction. When these particles, when they will come closer, very close to each other, then it will create a high pressure region. That is nothing but a compression. In the case of a longitudinal wave, there will be a continuous rarefaction, compression, rarefaction, compression, again rarefaction, compression region it will be forming until you have to, this sound it has to reach a particular destination. Okay, sound waves it will travel like this only in the form of a longitudinal wave. You know wave, this is the wave, this one is the crest, this one is the trough. The distance between the two successive crest and trough, it is nothing but a wavelength. This one is very basic. What is mean by amplitude? Amplitude is nothing but the height of the wave. This also I will explain in detail. Amplitude is nothing but a height of a wave. I am explaining in detail because those who don't know clearly about the sound waves, I am explaining in detail. I don't know, no one will watch the video up to full. We will see. Those who are there in the live, tell me hi, then I will come to know. Those who are there in the live, tell me hi, then I will come to know who is there. Okay, understood? Next one, nature of sound. The sound produced by a guitar is different from the sound produced by a drum. Yes, this one we know. We can differentiate the sound. Guitar, it will make different sound. The drum, it will make a different sound. This is because the sound produced by different source have different characteristic. What is mean by characteristic of a sound? Even person to person, how we will speak, how we will sing. Someone, they are very good singer, their voice is like a tuned voice. Even they will speech also we can recognize how nicely, how nice their voice. Someone we will tell their voice is very loud. Even we can recognize, we can differentiate between our own persons to person sound. Why we can differentiate, how we can differentiate, that is nothing but wave characteristic. Wave characteristic. Sound can be characterized by its frequency, wavelength and also amplitude. How guitar is making different sound compared to the drum means, the guitar frequency of guitar is different, frequency of wavelength of guitar is different, amplitude of guitar is different from the drum. Both also they have the different frequencies, different wavelength, different amplitude. You can differentiate. Okay, then what is mean by frequency of a sound? You can recognize even musical instrument, they are making different frequencies, high pitch, low pitch, then variety of sounds. Musical instrument, when they will play tuned otherwise in the particular pattern, then that it is, then it will create a music. Some music you can observe, those it will making a nice sound, then hours together you can hear the music. Some musician, how nicely they will play the instrument. Okay, that I will explain. That everything it will be based on the characteristic of a wave. How you can characteristic a wave based on the frequency, wavelength, amplitude, it will be different from one musical instrument to another musical instrument. Let us study what is mean by frequency, wavelength and amplitude of a wave. Frequency of sound. The number of rarefaction and compression. Yes, in the case of a sound wave, it is nothing but a longitudinal wave. I told. Then here you can observe the rarefaction and compression, it will occur. Then frequency of sound is nothing but how many number of rarefaction and compression it will occur per unit time, per 1 second. This is known as a frequency of a sound wave. The formula of frequency of a sound wave is nothing but F is equal to 1 by T. F is nothing but frequency of a sound wave, T is time period. Then easy words you have to remember. What is mean by frequency? Means number of rarefaction, compression, how many they will form per unit time, per second. How many number of rarefaction and also compression it will occur. That is nothing but frequency of a sound. Next one, wavelength of sound is this one is easy. The distance between the two successive compression and also rarefaction. Even what is the distance between the two successive compression and also rarefaction? Here what is the distance from two successive compression and also rarefaction? We will consider as a wavelength. Here also you can consider two successive crust and crust, trough and trough. You can consider this one also wavelength from here to here. Then from here to here, wavelength. Any definition you can consider is known as a wavelength of a wave, wavelength of a sound wave. The wavelength of a sound wave is given by the formula. This is small f lambda. It will be equal to mu divided by small f. Sometimes normally we will use small f. We will not use the capital one. Okay. F is the frequency of the sound wave. Then mu. This mu, not v. Mu is the velocity of the sound wave. Remember the formula. Next one, I told what is meant by amplitude of a sound wave is nothing but a height of a wave. When you consider the wave like this, then height of the wave is nothing but a amplitude. Simple words. The amplitude of a sound is the magnitude of the maximum disturbance in sound wave. What is the maximum disturbance? It will occur in a sound wave. That is nothing but a amplitude of a sound wave. The amplitude is also a measurement of an energy. When you will get the higher amplitude, when you are having more energy, when you will get lower amplitude like this. Okay, this is the lower one, lower amplitude. When you are having the less energy. Higher the amplitude, higher the energy in the sound wave. Human can hear a limited range of frequency of sound. Physicists have identified the audio frequency spectrum of the human ear between 20 Hz to 20,000 Hz. This is the audible range of an human ear. Under ideal laboratory condition, the human ear can detect frequency even less than 20 Hz, but this theoretically it is practically is not possible. Generally, we consider human can hear a frequency range from 20 Hz to 20,000 Hz. Audible, that is the audible range of a frequency. Okay. That is nothing but a amplitude of a sound wave. Then coming to the next one. Speed of sound wave. Speed of sound. The speed at which sound waves propagate through a medium is known as the speed of a sound. And which speed the sound wave it will travel, that is nothing but speed of a sound. Simple words. The speed of sound is different in different media. The speed of sound is higher in solid, already I explained this one, and it will be lower in liquid and also gaseous. Why it will be higher in solid? The interaction between the atoms in a particle is highly dependent on the distance between them. Higher the interaction between the atoms, the quicker the energy is transferred. In the solid, all the particles they will be very close to each other. Then interaction between the particles is very easy. Even energy also it will be easily transferred. Even vibration also it can transfer very easily. Okay, as the interaction of the particles in solid is high, the speed of sound is faster than liquid and gases. The table below listed the speed of sound in different medium. Solid it will be more. Then here the speed of sound it will be equal to d divided by t. D is the distance travelled by sound and t is the time taken to cover the distance. That one you have to remember. Speed of sound is nothing but, what is meant by speed of sound? Speed of sound is nothing but at what speed the sound waves they can travel. Okay. Yes. Okay, next one we will move to the next one. Here I given the list in different medium what is the speed of sound. Water it will be solid, it will be more. Copper C solid it will be more. 4600 solid it will be. Copper it will be the highest. Okay, glass also solid, this also it will be the highest. Hydrogen is gas is the lower one. See, water liquid lower one. Okay. Next, then what is mean by a sound? Sound is defined as a oscillation or auditory sensation evoked by oscillation in particles, displacement and velocity propagates in a medium with internal force. Sound propagates as a mechanical wave through a medium such as air, water. Already I explained that one. Then next one, coming to the next one, reflection of sound. How the reflection it will occur in the case of a sound wave. Reflection is there, echo is there, beats. Okay, I will finish this one. Reflection is very easy one. Just like the reflection of light, the reflection of sound is similar as it follow the law of reflection, where the angle of reflection is equal to the angle of incident and also reflected sound. The incident sound, the normal sound belong in the same plane. Sound bounce off the surface of the medium, which can be a solid or liquid. In order to make the reflection of sound to occur, the surface can be of larger size, can be either rough or polished. Here you can observe the reflection of sound. Here keep one wooden board. Okay. Then take the empty tube. This also empty tube, otherwise hollow tube we can consider. Hollow tube, not empty. Even empty tube also you can consider, even hollow. Consider a hollow tube. Background you are having the wooden board, because the sound waves they have to be reflect, correct? No. Then here keep here cardboard tube, otherwise hollow tube. Then here stop watch is there. On the stop watch it will make a tick 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 sound. Then keep one more hollow tube, both they will make an angle of incident it will be equal to angle of reflection of sound. Keep it with the same angle, cardboard tube. Then here once this stopcock on, then this sound waves it will travel in this direction, like this direction it will travel. Okay, then it will hit the wooden board. Then after hitting the wooden board, the same sound waves it will get reflected in this direction, then you keep your here, then here you are here it can listen the tick tick sound. This is nothing but reflection of sound waves. Here this it will be same as the reflection of the light. This is the reflected ray we can consider, otherwise this is the incident ray, correct? No, this one is nothing but the incident ray, or incident ray we can consider in light, otherwise here we will consider a incident sound. Then after it will get reflected. This is the reflected ray we will consider in the light, but here we will consider reflected sound. Here this is the normal soft wooden, consider this one as a normal. Then this one wooden board, this one is nothing but a reflecting surface. This is nothing but a reflecting surface. You can observe here, you can observe in this diagram reflection of sound, how it will occur in the case. See here, small, this one you can correlate with the reflection of light. This is the wooden board, keep one stop clock, it will make a sound, that is nothing but a incident sound. Once it will hit the wooden board, that sound it will get reflected. You can hear the sound at the another end of the hollow tube. Then this one is the normal. Then this incident ray, angle of incident, it will be equal to angle of reflection. Then this incident ray, reflected ray, otherwise incident sound, reflected sound, this normal, all they will lie on the same plane. Correct? Now you can observe all they will lie on the same plane. Therefore, this is also one of the example of a reflection of a sound. This one easily you can do it in your home also. Then law of reflection of sound, the angle of reflection is always equal to the angle of incidence. Already I told. The reflected sound, the incident sound, the normal sound belong in the same plane. This is the normal sound. This is the normal sound. This is the incident sound. This is the reflected sound. All they will lie in the same plane. Let us move to the next one, echo. What is mean by echo? This also very easy one. Echo, the sound heard after reflection from a distance obstacle. See, when you will produce the sound echo, normally it will occur in the empty space. Assume in your home you don't have any furnitures. When you enter the new home, you don't have any furnitures, nothing is there, even curtains, nothing is there. When you will talk, you can hear your own voice, that is nothing but a echo. What is the condition? In all the cases echo it will not occur. In which case the echo it will occur? What is mean by echo? The sound heard after a reflection from a distance obstacle. Obstacle is nothing but a, this is the obstacle, maybe wall, like that, okay, such as cliff and a hillside, etc. These are the obstacles like cliff, hillside, etc. After the original sound has ceased is called as an echo. Reverberation, if the distance is less than 17 meter, then the original sound mixed with the reflection of reflected sound. 17.2 sometime we can consider, otherwise approximately it will be equal to 17 meter. Okay, accurately 17.2, but we will consider the 70 meter. In which case the echo it will occur. The distance between the observer and also obstacles it will be exactly 17 meter or 17.2 meter. At least that time you can hear the echo. Once you will produce the sound, then this sound it will hit the obstacle, then it will come back. Okay, this is the original sound you produce, it will hit the obstacle, this is the arrow mark, then it will hit the obstacle, then the reflected sound it will reach your ear. Okay, this echo it will happen only when you are not having any other disturbance. Okay, maybe mountain, hills, cliff, empty home, new home, then you can observe the echo sound. Then what are the application of echo? Then after this one I will stop, otherwise it will become too lengthy. Then what is mean by beat, everything I will explain today only. I will make one more video, because too lengthy means no one will listen. Application of reflection of sound. Echo, the sound heard after a reflection from a rigid surface such as cliff or a wall are called as a echo. creating a persistence of sound even after the source of sound has stopped vibrating. Yes, you can hear the echo sound. Even how, what is the use of the echo sound? Application of reflection of sound is one of it, nothing but echo. Then here the sound heard after the reflection from a rigid surface such as cliff or a wall are called as a echo. Again here this point is explaining what is meant by a echo. Once you produce the sound, it will hit the obstacles or a rigid surface. Once again the same voice we can reach, we can listen. That is nothing but a echo. Then what is the use of that echo? Echo creating a persistence of sound even after the source of sound has stopped vibrating. Even you can listen the echo once you stop producing your own voice. Continuously you can hear the echo. Echo maybe 2-3 times it will happen. Why 2-3 times it will happen means again that same echo it will be get repeated. Assume here one person is standing, he will produce one sound hello, otherwise some name he will call. Again that it will hit the rigid body, again it will come back. That same echo, this echo. Then that same echo it will make a multiple reflection, it will make. Same echo, same hello, Ashok I will call, otherwise some other name I will call. Okay, I will call my name itself Sunita, I will call only one time. But here this echo we will listen 3 times. Only one time I produce the sound Sunita. But 3 times why I can hear the sound, same sound 3 times means again that same echo it will takes place multiple reflection. That is the application. One of the best application of an echo. The echo is caused by bats, dolphins to detect obstacles or to navigate. What is the use of the echo? Only for fun purpose we will not use. To detect the obstacles, we don't know what is the obstacle. To detect that one, even navigation purpose we will use that echo. The same principle is used in sonar. This is very important. Abbreviation they will ask in the exam: sound navigation and ranging technique. Sonar is nothing but sound navigation and ranging technique used in oceanographic studies. Yes, even oceans, under the ocean we are having so many objects, even living things, non-living things, everything it will be there. Then to see that one we will use sonar. Sonar is used for the detection and location of unseen underwater object, even unseen underwater object. To see an underwater object, we will use the sonar. Sonar means sound, navigation, ranging and technique. Such as submerged submarine, sunken ships, icebergs in sonar. Ultrasonic waves are sent in all the direction from the ship and receive the signal is analyzed. Here how the sonar, how will work? See, underwater we are having so many obstacles are there, even living, non-living things are there. This is land, this is underwater like sea you can consider. This is underwater. Then here ultrasonic waves they will send. Here assume they are having the instrument, then they will send the ultrasonic sound waves they will send. Then here any obstacles, any object is there, then this sound it will hit, then it will start reflecting. Then that reflected sound you can decide which object is there, what is the distance between the object from the top, how much depth, what is the size, everything you will come to know based on the technique. That is nothing but a sonar. Sonar is very useful, very useful, we can use that. See here receiver, see here receiver like a sound waves, it will move. This is the object, this it will get reflected in the opposite direction. Okay, up to here almost like 45 minutes over. I need one more class to cover the topic sound waves only. I will do one more theory class now 3:35. 3:45 within after 10 minutes I will start one more class. Those who are there in the live, please watch the live class. Those who are not able to attend my live classes, please I'm requesting, support my video, share my video, subscribe. When you are free, watch my videos. This definitely it will helpful for your upcoming exam, hstr, tet, gpstr, all the exams it will be helpful. Those who are not still, those who are not applied for ctet, 26 is the last date to apply ctet. Better first apply for the exam, then sit, read, start preparing for the exam. At least 2 months they will give the time, prepare, then easily you can clear the exam. Okay, thank you everyone, thanks for listening my class. Please support my video, share the video to your friends and subscribe. Then whenever you are free, please watch the video. Okay.